Hi, so today in this video, we are going to be covering chapter 5.4, which is the algebraic analysis of an intersection points. Now, this one is a little confusing initially, but basically what we are trying to do is solve for x, I guess, basically. I think we're basically trying to solve for x. This is not the chapter where we introduce log functions, but we will get into that. Or at least I'm pretty sure this is not the chapter where we introduce log functions. Basically, we're just going to be doing the things that we know. So we are dividing both sides by 32 to get x. We want to get x by itself. So we'll divide both sides by 32, which equals 2 to the x minus 2 equals 1. Now, if you remember, the way that we can get 1 is if we have 2 to the 0, or anything to the 0. So we need to turn this to the 0. We need to turn x minus 2 into 0. How do you do that? Well, 2 minus 2 equals 0. So your answer will be 2. Same idea for this. We're going to divide both sides by 9, which gives you 3 to the 4x plus 3 equals 9. Now, things get a little bit trickier, but we know that 3 squared equals 9, right? 3 times 3 equals 9. So we need to turn this into 2. So we have 4x plus 3 equals 2. Another way to write this is, or to get to this step, is we want the same basis, right? So let's turn this into 3 squared. 3 squared is the same as 9, right? So it stands to reason that 3 to the something, if it equals 3 to the squared, this will also equal 2, right? So that's why we're able to have that 2 there. So now we'll have 4x plus 3 equals 2. We'll minus 3 from both sides. So we have 4x equals negative 1. That will be x equals negative 1/4. Yes. Which, if we check that, it would be correct. So we'd have 3 to the negative 1/4 times 4, which is negative 1. Plus 3 equals 9, which is 3 squared equals 9, which is the same as 3 squared. But yes, yeah, so that's true. That's correct. That would be your answer. X equals negative 1/4. Solve the following equation. Express your answer as either an integer or a fraction in lowest terms. This is where what I discussed in the last problem, where that comes in handy. We know that both 16 and 18, both of those can be achieved by doing 2 with, like, we can have a base 2. So 16 is the same as 2 to the 4th, right? And 8 is the same as 2 to the 3rd, right? So what we can do is 2 to the 4th and 2 to the 3rd for our bases, because this doesn't change the value, right? But now what we can do is multiply x plus 4, because this is the same as our base, 16 to the x plus 4 and 8 to the 2x minus 1. Now what we can do, we can multiply, we can sort of distribute. So we have 4x, so 2 to the 4x plus 16 is equal to 2 to the 4x minus 2. And now we know that if these have to be the same, we can solve for x. So we'll just imagine that there's no 2 there. We can do 4x plus 16 equals 4x minus 2. So we'll minus 2 from both sides. Wait a minute. I'm doing something crazy wacky. Hold on. The reason why I'm being confused here is because we would have 0 is equal to 14, which is not true. So I think I'm doing something wrong. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have that right, and then 3. Hold on, give me just a second to think. Oh, okay, I accidentally did 2 instead of 3, so I'm not sure what I was up to. So instead that would be 6x minus 3, so 6x minus 3, obvious. Okay, my bad. I knew that it was to the cubed, but I'd written it wrong. So we have 2x, and then equals 7. So you will have, wait, hold on, sorry, restart. We will minus 4x from both sides, which gives you 4 is equal to 2x minus 3. And then we'll add 3 to both sides, so you get 7 equals 2x, which will give you x is equal to 7 over 2, but it's still saying that's wrong. It says it's 19 over 2. So what I'm going to do is I'm going to troubleshoot by plugging in answers that I know. So if we have, hold on. I don't think I want it to be a fraction. Okay. Sometimes the best thing to do is just to restart the problem. I think I got confused, and so I'm going to do just that. I'm going to do, so 16 is the same as 2 to the 4th. Then we still have the x plus 4. And 8 is the same as 2 cubed to the 2x minus 1. We can distribute, so we'll have 4x plus 16 is equal to 6x minus 3. We're going to add 3 to both sides, which gives you 19. We're going to minus 4 from both sides, which gives you 19 is equal to 2x. Okay, I just was being confused. This is the right answer. 19 divided by 2 is equal to x. I just was like confusing myself. I just was doing the wrong little math mistakes. It's not that I didn't know the process, it's that I messed up a little bit. And that is the case for a lot of you, I'm sure. Try not to get discouraged, because a lot of times it's just you need to restart and you'll get it. Determine the intersection point of the functions g of x equals 2 to the x and h of x equals 2 to the 2x. 2 times 2 to the 2x. Express your answer as an ordered pair with the coordinates in decimal form, rounded to the nearest 4 decimal places. Now, what I would think on this one is that we probably are trying to set them equal to each other. So 2 to the x is equal to 2 times 2 to the 2x. And hold on. Let me think about this for a minute. Okay. If you remember, we have 2 to the 1. 2 times 2 to the 2x. When you see a 2, you can assume that it's to the first power. When you see any integer, you can assume that it's to the first power. Like if you see 999, it's going to be 9 to the first. There's an implied 1 there. And it's important to put that back in when we're doing this. So this will be 1 plus 2x. So we'll have 2 to the x equals 2 to the 1 plus 2x. And now we can solve. So we have x equals 1 plus 2x. We'll do x, negative x is equal to 1. X is equal to negative 1. That would be your answer. For x, if x is negative 1, we need a coordinate pair. So negative 1, comma, and we need to find our intersection. But we can do that by plugging in our answers. So we have 2 to the negative 1 equals, equals 2 to the 2 times 2 to the 2 times negative 1, which is the same as 1/2 equals 2 times 2, which is 4. Oh, wait, hold on. Give me just a sec. Okay, I accidentally did the math wrong. So when I was calculating with it as negative 1, I had 2 times 2 to the 2 times negative 1. And 2 times negative 1 is not 2 minus 1. It is negative 2. So 2 times 2 to the negative 2, which is the same as 2 times 1 over 4, which is the same as 1/2. Yes, 1/2. So both, it's 1/2 equals 1/2. Our y point is going to be 0.5. So we have negative 1, 0.5, because it wants it in decimal places. So this would be our answer. I just messed up. You do plug in your what you find for x into your y. Determine the intersection point of these functions, and then it expresses an ordered pair. So we'll do the same. 4 to the 3, x minus 4 equals 36 to the 3 squared to the 3 to the 2x minus 3. Going to divide 4 from both sides. So like 3 to the x minus 4 is equal to 9 times 3 to the 2x minus 3. Whoops. What I can do with this, 9 is the same, so 3 to the x minus 4 is equal to 3 squared, because that's all 9 is, right? Times 3 to the 2x minus 3. That's two exponents with the same base multiplied together are going to be adding. So we'll have 3 to the x minus 4 equals 3 to the 2x minus 3 plus 2, which is going to be negative 1. So 2x minus 1. Then we can set it equal to each other. So x minus 4 is equal to 2x minus 1, which is the same as, we're going to add the 4 over, minus the 2. We'll have negative x is equal to positive 3. Positive x is equal to negative 3. And we could check it, but I don't feel like it. If you have any questions, please let me know. I know that this one's a little bit more tricky, but it's really just thinking outside the box with the rules that we have already been given. Yeah, have a good one.